Hi folks, we're going to take a look at 15D from page 268. So they're asking us to find the extreme values of this function on the interval 0 pi inclusive. Okay, so first thing to notice here is we've got a continuous function that's defined over this closed interval, so we know that there are going to be extreme values and they'll occur either at the endpoints or at critical points. So when the derivative is equal to 0, and I'm not going to bother with where it doesn't exist because this is also a differentiable function. Okay, so let me start by determining the values at the endpoints. So f at 0, this gives us sine of 0, which is 0, so plus 3. And if we check f at pi, okay, we get sine of 4 pi, which is also equal to 0, so this whole thing will also be equal to 3. Now, by the way, I should mention that we should be able to solve this problem without having to use calculus, since you can just work with the transformations on the sine function, but we'll use calculus methods as practice here. Okay, so now we'll find the critical points. So f prime at x is going to be equal to, 2 is just well, first of all, derivative of 3 is just going to be 0, so we don't have to worry about that, so 2 is just a constant. So derivative of sine 4x, we're going to have to use the chain rule here. So derivative of sine is cos, so we have cos of 4x, and then multiply that by the derivative of 4x with respect to x, which is just 4. So here we've got the derivative function is 8 cos 4x. Okay, and we're looking to see where the derivative is equal to 0. Okay, so since 8 is just a constant multiple, got to figure out where cos of 4x is equal to 0. So we know that cos is equal to 0 when the input is equal to pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on and so forth. So here we need 4x to be equal to pi over 2. Okay, 3 pi over 2. Now here we've got a horizontal compression of our function, so we should expect to have more answers here. So let's keep going with a couple more. 5 pi over 2. Okay, 7 pi over 2, and let's solve for x here. So divide by 4, so pi over 8, or 3 pi over 8, 5 pi over 8, 7 pi over 8. Okay, and I think that's all we need, because here if we go further, we'll have a number greater than pi, and here obviously if we go into the negatives, we'll have a number less than 0. Okay, so these are the locations of our critical points, and so now let's determine the function values at those points. Okay, so if we look at f at pi over 8, okay, if we put pi over 8 into here, 4 times pi over 8 is pi over 2. So sine of pi over 2 is equal to 1, so not surprisingly at its maximum. But of course, if we also put 5 pi over 8 into here, we end up with 5 pi over 2. Okay, so sine of 5 pi over 2 is also equal to 1. Okay, so these two will actually be equal. Okay, so we have 2 times 1 plus 3 is equal to 5. Okay, so already that's larger than those two. And now we'll check f at, what do we have? 3 pi over 8. Okay, and if we stick that in here, we end up with 3 pi over 2, which of course is where sine is equal to negative 1. Okay, but if you also stick in 7 pi over 8, 4 times 7 pi over 8 will be 7 pi over 2, where sine is also equal to negative 1. So these are going to be equal. Okay, so 2 times negative 1, negative 2 plus 3 is equal to 1. Okay, so based on this here, our maximum value is equal to 5, and our minimum value is equal to 1. Okay, so again, just to recap, when you've got a continuous function on a closed interval, the extreme values can occur at the endpoints or at the critical points. Okay, that's it for this one.